So I want to look a little bit more detail now on the timing of these engines, of the events that are happening within the engine, specifically centered around the valve timing. And we talked about how critical that is, that these valves open and close at exactly the right time relative to the position of that piston, and how those camshafts that are controlling that valve motion have to be tied directly to that crankshaft. So whether it's a belt, whether it's gears or something there, to make sure that that crankshaft and those camshafts are all turning at exactly the same speed relative to each other. So let's look into this a little bit. And first of all, I want to talk about a little bit of adjustment, and so what kind of adjustments we have to do on the valves. And here's the critical thing. So we want to make sure that when that valve closes, as we see here, we want to make sure that that valve stays completely seated, perfectly seated down there, so that all the combustion and everything in there stays in the chamber, and we don't let it out until we want to, until we open the valve and then let it out. So the way that we maintain that is that we have some clearance in that system somewhere. So if you look at the camshaft down here in this drawing, the camshaft should be down. So I have the nose of the camshaft is away from the valve tappet there, or the valve lifter, and so that should be letting this close. But you notice that there's a little bit of clearance right there in between that lifter and that valve, and we want to build that in, and that clearance, that distance, is specified for any particular engine. So each engine will have a specification, so many thousandths of an inch or millimeters or whatever the specification they give, so that clearance stays there. And that's for a couple reasons. Again, we want to make sure that that valve goes closed. There's nothing holding it open a little bit, because if there's a little bit holding it open, we're going to have some of those hot gases, those hot combustion gases that are sneaking out. They're squeezing through that gap between the valve and the valve seat. And that will, in very short order, destroy that valve seat. So it'll damage it, it'll burn it, and then it won't seal even if we adjust it carefully. So that's why we want to make sure that there is some clearance. If there's no clearance, it might hold that up and we can have problems. The other thing is that this will affect the timing a little bit. So if you think about this, as this camshaft rotates around, then we start to come up onto the nose, or up on the land of that camshaft there, and as we do, that's going to start moving this tappet up. So that tappet will have to move a little bit before it actually hits the valve. So if that clearance is too large, if there's a lot of clearance right there, it'll take a little while, a few extra degrees of rotation before that land gets high enough to actually open a valve. And that's going to delay when that valve opens, and it's going to open too late. Likewise, if that clearance is too small, that valve is going to start to open a little bit early when that camshaft comes around. So this clearance does affect that timing a little bit. So the major part of the timing is where the rotation of this shaft is, or where we put the high spot on the cam, if you will. So how that cam is manufactured. That's the main part of it, but all that clearance will also affect the timing a little bit. Okay. So now on a direct control, where the camshaft is pushing directly on the valve, like on an overhead engine, or on an L or I head engine, like we looked at earlier, that clearance is going to happen in there in that tappet. On engines where you have rocker arms, like the ones that we're using in lab for this class, that clearance is going to happen between the rocker arm and that valve. So in our case, the camshaft is actually down here with a push rod, and so we want to look at that clearance there. So we'll have to make sure that when we check that the camshaft is not on a land like you see now, because there is no clearance. It's pushing the valve open in this picture. So we need to make sure that camshaft is rotated to a position where it's on the low spot, and then we adjust the clearance there. So there's a couple different ways we can do that. There's different adjusters, and different manufacturers will do it a little bit differently in every engine. So you got to learn for your engine how you do that, what that clearance is, and how you adjust that engine. So that's the adjustment. That's the main thing that we have to watch in terms of the engine maintenance. So other than that, if parts are worn out, either fix them, either clean them up and regrind them, or replace them. So that's the maintenance part of it. But now let's look in a little bit more detail in the timing. And I want to look at this timing graph. And so this is kind of a complicated thing, but I want to take a few minutes to unpack it, because it really starts to show all the events that are happening in this engine and when they happen. And we've talked about a lot of things. We've talked about the spark on a spark ignition engine. Then it happens a little bit before top dead center. So we have that flame front has a chance to get started. But we're also going to see that there's some things happening with the valves as well when they open relative to that piston position. And so let's take a look at this. And this is the timing diagram. And if you follow it, it's kind of like a spiral. And basically, this is the rotation. The spiral is the rotation of the crankshaft. This is a 4-stroke engine. So in a 4-stroke engine, you've got 2 rotations of the crankshaft for every 4 strokes. And so there you see this rotation. Start around the black circle. We go around into the purple, into the yellow. There's 1 rotation from the yellow around to the blue and back up to here. That's the 2nd rotation. And it's giving us a complete picture of what's going on. And we see a lot of labels up here and see what's happening. So let's kind of follow through this and understand what's happening. So this location at the top here is top dead center. And if I look at my engine, and I'll actually draw it on my engine here, so looking at my crankshaft over here, the physical engine, this would be when the crankshaft is clear at the top. So I'll actually put a mark on there so that crankshaft, blue mark, crankshaft is straight up and down. That's top dead center. So if I rotate this crankshaft clear around, that it's pushing straight up. The piston is as high as it can go up into the cylinder, up into the combustion chamber. That is top dead center. That's when I'm right here at this position. So you notice in this timing diagram, we actually start a little bit early. So we start before top dead center, and we have a mark here, A, and it says this is where the intake valve opens. So that intake valve opens actually before we get all the way up. So this is at 10 degrees before top dead center. So if I put a mark on here, 10 degrees before top dead center, I'll put another line over here at about 10 degrees to the left. I'm kind of taking a guess at that. So before that crankshaft gets clear to the top, that's when that intake valve starts to open. So it opens up there. We get up to top dead center. That intake valve stays open. So this is going to be my intake stroke. So now as I go past top dead center, the crank goes past top dead center, I start coming down my intake stroke. This is the black line. Intake valve stays open. The piston comes all the way down, all the way down. And look at this. The intake valve still stays open quite a ways past bottom dead center. So we've gone all the way around. The crank has come clear down to the bottom. Bottom dead center is down here. There's bottom dead center, clear down there. And it actually goes past that. It actually goes over to like 45 degrees, so it goes pretty far past, and that intake valve is staying open. Okay, so what's going on? Why does it stay open? Doesn't this piston start back up? Well, it does, but you got to think about the motion of this a little bit. So you got to kind of focus and look at what's happening. So think about that piston. As my crankshaft is near the top, if that crankshaft moves back and forth near the top up here, that piston is not moving very far. So the piston moves really slowly when my crankshaft is vertical, either at top dead center or at bottom dead center. When it's down at bottom dead center, that piston is not moving very fast, so it's just moving really slowly. When the crankshaft gets over to the side, gets at 90 degrees, then it's moving fast. So it moves real fast all the way through, slows down at the top, goes slow at the top. Then moves fast coming down and then slows down at the bottom. So it's kind of a sinusoidal motion. Goes fast in the middle, slow on the ends. So when it's sitting down here at the bottom, even when I get over to like 45 degrees, that crank goes over. Yeah, the piston has started back up, but it hasn't moved very much. And see, here's what happened. There's a lot more going on in there with those gases moving in and out of that combustion chamber. So as those gases are coming in, they build up momentum. So it's like you get this airflow, and the air wants to keep on going. So when those gases are coming in, I'm coming down to that intake stroke. When that piston's going really fast, I get a big suction. It gets that air pulling in, and then I get momentum. And the molecules that are going in kind of pull more molecules with them on that intake stroke. So I want to leave that happen as long as I can. So even though the piston has started back up, there's still momentum up in the top of this chamber pulling those particles in. And I want to get as many of those air fuel molecules in there as I possibly can. I want to pack that thing as full as I possibly can. So I want to leave that intake valve open as long as possible. So at 45 degrees, I'm already started back up. That's when I'm finally going to close that valve. So I close that valve at 45 degrees. So now I get my compression stroke. So I got compression coming up all the way around. My crankshaft keeps moving, moving, moving. Compression all the way almost back up the top dead center. And then look, we actually see right here at 30 degrees before top dead center. And I'll put another line on here a little bit further to the left. So at 30 degrees before top dead center, that's when I'm going to have my spark. So the intake valve is closed. The exhaust valve is also closed at this point. Compression stroke coming up here. My spark happens 30 degrees early, so my spark happens here. So now I go on through, go past top dead center. Here's where the pressure, my piston's gotten to the top. The pressure has built up. Now it's pushing that thing down, pushing, 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 and here we go. So I get a lot of pressure pushing down there, okay? Now I got something happening down here. The exhaust valve opens. Look where the exhaust valve's open. It's open way early, so like 60 degrees. So I'll put another mark over here at like 60 degrees. So when my crankshaft is over here, coming down in a power stroke, this is where the exhaust valve opens. So here's my exhaust valve open right there, 60 degrees before top dead center. Again, why so early? I want to have plenty of time to get all those gases out of there, but it's going to take some time for a few milliseconds for that valve to open up, a few milliseconds for that gas to start to move out of there. I still am going to have this gas expanding in there a little bit, so even though some of it is sneaking out, it's still giving me some pushing. So it's still going to do some pushing all the way to the bottom. Then I want to make sure at the bottom I'm done. And now when the piston starts back up, now I can start shoving that gas out of there. So I start pushing it out. So the pressure, high pressure in there has started those molecules moving. And guess what? We have more momentum happening. So those particles going out kind of get a momentum. They get a gang effect. Everybody's starting to run. It's all going out there. And we get some momentum and we actually start to pull the stuff with it. So not only is that piston coming back up, in the exhaust stroke, it's coming back up. It's pushing, 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 pushing. But it's also getting that, the momentum of those particles leaving is actually pulling more particles out. So here's the crazy thing. So I get up to here. This is where my exhaust stroke, the exhaust is still open. But now when I get to this point, I'm back up to the top. I'm ready for my intake stroke. I finished the exhaust stroke, and I'm ready for my intake stroke. And this is where we would actually start over up here. But look, this dotted line goes, the blue dotted line goes past. So that exhaust valve isn't going to open until I get over past vertical. So I get over at like 30 degrees past. So something like this is where the exhaust valve is going to open. But look what's happening here. The intake valve opens here. So the intake valve opens before top dead center. So I actually have a point in time where the exhaust valve is open, this piston is coming up. Before it gets to the top, the intake valve also opens. So both of them are open at the same time. Why would I do that? Well, again, it's this momentum thing. So I've pushed this gas. I've got this gas running, this gas moving out of there. It actually will create a little bit of a vacuum in that piston. Because I've shoved it out, I've got it all moving, I've got that momentum. There's a little bit of a vacuum in there because all those exhaust gases took off and headed for the hills, right? Headed for the muffler. And so if I open this intake valve a little bit early, that little vacuum in there will actually help to bring in a little bit of extra air. So it actually kind of jump starts it. It gives me a little initial suck on there from that the exhaust gases going out. They'll pull some of that intake gas in. And so I leave them both open at the same time. It's kind of the same concept that's going on in a two-stroke engine where I've got the exhaust gases going out and at the same time they kind of pull some intake gases in with them. So they're kind of, as one vacates, it pulls the other ones through. So I let some of that intake come in And hopefully before very much or any of that intake gas goes out the exhaust, then I'm going to close that exhaust valve. So that's why the exhaust valve closes then at about 30 degrees after. The intake valve is completely full. Now the piston comes back down and we start all over. The piston is going to be pulling that gas in. So we start that whole cycle over. So there's some overlap in here. So again, here's some terminology that we want to remember. There's what we call valve overlap. Valve overlap means that's the time in the cycle where the intake and the exhaust valves are both open at the same time, which kind of seems weird to us until you think about, oh, that exhaust gas is running out is going to kind of pull some stuff in behind it. And that's what's going on there with us. Okay, so some overlap there. But this is the timing cycle. This is what I want you to get used to looking at. Now, this is a timing cycle that's typical for a small gas engine like we're looking at in lab. But a lot of engines might be a little bit different. They might have a different advance on the spark here. And in fact, it might be variable when we get into talking about electronic controls on engines. This advance might be variable. So as the speed goes up, they might make it a little bit earlier. And the lower speeds, it might retard it a little bit, make it a little bit later. We do have the capability on some really modern engines to change the valve timing a little bit. So there's some hydraulic systems and different hydraulic lifters that you'll hear about, and they'll allow us to actually change this valve timing a little bit. And we can do that based on engine speed. So have them start a little bit earlier, a little bit later. So there's a lot of things going on. And again, these degrees might be a little bit different for different engines. So the 45 down here for the intake valve, or the 60 degrees for when the exhaust valve opens up. Those kind of things may vary by engine, but this is somewhat typical, and it's a cycle. This timing diagram is something that we need to get used to looking at and be able to interpret and understand what's going on. So that's engine timing a little bit more in detail. Again, we kind of danced around that and a lot of other things, but now we're really starting to zero in to try to understand what's going on. Again, key things here: understand this diagram, be able to interpret this diagram and see what that means. Understanding why there's some overlap and stuff in there, why the valves don't open exactly at bottom dead center. So, we got this momentum thing where we've got the gases moving out, pull gases in with it. So we open both valves to kind of make that transition happen. So a lot of these things that are happening in the engine. So that's valve timing, valves, and so forth.